If you turn this video at one point off, then please tell me what the reason for it was so that I can improve. Otherwise, hi, welcome. I'm trying to learn Heliology, today T Tauri stars, and after we've done it, we're gonna do stretching, and if you participate in the stretching, then it's at your own risk. T Tauri stars. A star's T Tauri phase is violent. The star is still undergoing gravitational contraction, but is not yet hot enough to drive thermonuclear reactions. Okay, we had the first phase of a protostars. It was a big thing, a giant molecular cloud. And that's at that place where it is more dense, the material of this big giant molecular cloud, which is more than a light year across, where it pulls itself together, and it starts more and more to pull itself faster and faster together. It's also turning, and it's pulling itself more and more together. And through this pulling together of this one light year across, so very big, it gets more hotter in the middle, and it goes to the middle and hotter, and there's a gas thing, and that gas thing starts to glow, and it gets warmer and warmer. And we are at that phase now. And that is now the T Tauri phases in there. It's hot there, the gravitational contraction, so that all falls together is still happening, but it's not warm enough for thermomolecular reactions. However, with sufficient hot surface temperatures of around 4000 degrees Celsius, virtually all its gases are electrically charged. Okay, there we have it. It seems to be just through having the temperature of 4000 degrees Celsius that these gases are now electrically charged. In a gas, atoms are usually electrically neutral because they are made up of equal quantities of positive and negative charges. So a gas is neutral. There are positive things and negative in them, but it's equal amount of each, so there's for every positive one and a negative one. It's neutral at the end of the day. But if a gas is hot enough, the heat shakes the atoms apart. This is known as ionization, and the charged atomic fragments are called ions. So the heat shakes or breaks them apart. That thing is then called ionization. And these fragments of these atoms are then now called ions. So, a T Tauri star, like a true star, is a gigantic ball of electrically charged gas, a plasma. Ionization. I know that in thermal science, if you make a gas to plasma, the process is called ionization. The process from ice to water is melting, and the process from gas to plasma is ionization, the backwards recombination. So it seems to be ionization is the process, and this happens when gas becomes plasma. We also know that the process is known as ionization, and that they are now ions. We don't really understand it, but we have a little idea what we're talking about. Compared to a star like the Sun, the average T Tauri is typically a few times larger and spins more quickly on its axis. Once in a few days, the Sun takes a month. There we have it. The Sun is spinning in 1 year around its axis. That's the first thing. And the other thing is, now such a T Tauri star is bigger than the Sun, which is one of the solar system with the humans living. And it's also turning faster. The Sun needs 1 month. Since a moving charge constitutes an electric current, a moving charge is an electric current. Why? Because it is charged, and it is moving, so it is a current. A current is nothing else than, as far as I understand it, electrons which are moving from one place to another one. That is current, electricity. Since a moving charge constitutes an electric current, the star's interior is full of electricity. Just as a wire carrying an electric current generates its own magnetic field, the circulating ions inside a star create a global magnetic field. Okay, that thing is turning. We know it is even faster turning than the sun once in a month. We know that all the gas in it, because it was heated up, has shaped up, broken up in a process called ionization, and are now fragments called ions, and it is now no longer a gas but a plasma through the process of ionization. And we know that they have become electrically charged. Why, we don't really know, but before it was always a positive one and a neutral one, a positive and a negative one, together neutral. Now they are broken up and now they are electrically charged, whatever. Because maybe, I still don't know why it's not electrically charged. Maybe because there are now some fragments which are not having the positive on it, whatever. It's electrically charged and it's moving around, so it's an electric current moving. And an electric current, we did with recently in electrical engineering in another course next to Helioscience, that any current has around it a magnetic field. And now all these electrons inside of this big moving large Tauri sun having a magnetic field. And now the circulating ions inside a star create a global magnetic field. In the case of a Tauri star, the rapid rotation creates a much stronger magnetic field than in normal stars. Okay, because Tauri stars are moving faster, the magnetic field is bigger. I don't really know why. Furthermore, a Tauri star is usually surrounded by the protoplanetary disk that built up around it as it grew. As the star rotates, its magnetic field lines are dragged through this disk. Where the field and disk interact, streams of gas are sucked out of the disk and pulled along the field lines onto the star's surface. Where these packets of gas hit, the star responds with violent magnetic flares, a hallmark of the Tauri phase of star formation. Every current has around it a magnetic field, a line of a magnetic field. At that place where, like a magnet, you can pull it there, nothing, but when you hit it, and now the magnet pulls or repels. And the Tauri star is rotating, and it has at the outside these magnetic fields. And just like if a magnet would come there, then it would react. If a magnetic field hits one of these rocks and starting to become planet things, these protoplanets, was it called, I think? Protoplanetary disk. I think lots of rocks and protoplanets and the things which become later planets, it is going through them with a magnetic field, and when it pulls the electrically charged things to it. They're saying here the gas, I don't know why just the gas or whatever. Now the gas is now pulled towards the Tauri sun, and as soon as they hit, there comes a violent magnetic flare, which is a hallmark of the Tauri phase of star formation. I don't know why. It starts suddenly to burn, whatever. There's a violent reaction as soon as these gases are pulled in and have hit the sun, or the Tauri star, the forming star, the sun. A final characteristic of a Tauri star is a powerful stellar wind. That is a stream of ions that blasters away from the star, deep into space. The sun has a similar wind, but it is much slower and more rarefied than the one on its Tauri adolescence. Okay, there can be suddenly a stream of ions pushed out for whatever reason, deep into space, and they are called stellar wind. The sun of a solar system in which the humans are also living has that also, but not so often, and they are not so strong. Okay, we have the basics. Well, Tauri phase, it is after there was a big field of giant molecular cloud of something, interstellar dust, interstellar fog. And because some areas are more dense than other ones, these areas have now become, just because something exists there, has started to pull other things in with gravitation, and faster and faster, has it pulled it all together, and it's basically collapsing on itself faster and faster. It creates heat in the middle, and this heat causes to become electrically charged. These particles in it are not electrically charged. And that all also has to do with ionization happens when during the time also, so it becomes plasma. And it is now, the electrons are moving, that thing is spinning, and because they're moving, we're having an electric field around them. That thing creates a big magnetic field. This magnetic field swipes through the other rocks around it and pulls them also the gases in, and that creates then violent reactions which are hallmark of Tauri stars and also have the ion bursts out. They are also hallmark of Tauri stars. Now I think we have something else here. Main sequence, nuclear powerhouses. The length of a star Tauri phase. Yes, we're going to have another page to the star formation. We had decided to reach first this page about the Tauri stars before we're going to do a presentation or properly about the protostars, so we know where it comes to. Now we're going to go on and we're going to read the next thing also as the next thing. Maybe after we've done it another time. And we're going to go through and read it. That means if you were here for helioscience, you're going to direct it to the next part of heliology. If you stay here to heliology, then we're going to continue with this reading. If you stay here and participate in the stretching minutes, we're having the feet standing together, and we're going a bit down into the knees, and we're opening the front toe and the other one, with the heel and with the heel, with the toes and the toes, heel, heel, and so on. And again, toes, toes, heel, heel. But now stay down, go into the knees. Now if the legs standing shoulder wide apart, breathe in and lift the arms up. Breathe out and go to one side. Breathe again in. Out over to the other one. In and back. Out and down. Breathe again in. And breathe out. One hand slides down the leg, the other shoulder stays down. Breathe again in. And out one arm over. Breathe in and out the rib cage. Again out back into the middle. Breathe again in. And out one hand slides down the leg and the other shoulder stays down. Breathe again in. And out one arm over. Breathe in and out the rib cage. Out and back. Have the feet standing together. Breathe in and lift the arms up. And breathe out one hand down. Breathe in and reach. And out hand up. In and reach. Out one hand down. In and reach. Out and up. And out. Have the legs standing again, shoulder wide apart. And we're doing shoulder circles back, up, in front, and down, and around. And backwards, front, up, back, and down. Breathe in and lift the shoulders up. And breathe out, let them fall down. In and up. Out and down. Breathe in, lift the arms up. And breathe out, or whatever. Breathe in and out regularly. Reach high, pretend to take an apple, hanging high on an apple branch. Pretend to turn it around and then to plug it out. And legs wide apart, arms up to a T, breathe in. And breathe out and shift over to one side. Breathe again in. And out over to the other one. Again in. And out, we're leaning onto the knees. Breathe again in. And out, one shoulder in the front. In and back. Out, the other one in the front. In and back. Out, one in front. Back. The other one in front. In and back. And out, and we're hanging down. Breathe again in. And out over to one leg. Breathe again in. And out over to the other leg. Breathe in. Out into the middle. Nose to the feet. Breathe in. And out comes slowly with the rope back up. and make it the top backwards, shoulder down. Legs wide apart, breathing down. And breathe out. Up. Down. Breathe in and close the legs. And breathe in out. This was the stretching. I thank you very much, and until next time.